Okay, now we're going to talk about some characteristics of sound in terms of physical characteristics of the sound wave and perceptual characteristics of how we hear those sounds. So first, we're going to talk about frequency and time. So a periodic wave repeats. That's what periodic means. The wave has a period, so it repeats at some level. Frequency is how often the wave repeats. So that's measured in hertz, or cycles per second. You'll hear the term hertz used in a lot of ways. It always means cycles per second. So we perceive frequency as pitch. So the faster a wave repeats, the higher the pitch. The slower a wave repeats, the lower the pitch. A sound that is not periodic, that does not repeat, we hear as noise. So aperiodic or non-periodic things sound like noise. So if I do something like ooh, I'm making a repeating wave, so you hear that as a pitch. But if I just go shh, that's a non-repeating wave. It's just sort of random air through my teeth. So that sounds like noise. So the physical quality of the wave is frequency, and the perceptual quality that we associate with frequency is pitch. Amplitude is another physical quality of a wave. The amplitude is the intensity of the pressure variation or the distance from zero, and we perceive this as volume or loudness. So if we look at this view in which this is time and this is amplitude, so the amplitude increases, so this is the pressure going up, the pressure going down, getting back to zero. So the distance from the 0 point to the highest and lowest points of pressure is the amplitude. This period of time is the frequency in the left to right. So if this were 1 second, then this would be 1 cycle per second. That would, of course, be too low for us to hear. We'll talk more about that later. So amplitude is the physical property of the wave that corresponds with loudness, which is the perceptual property. Frequency is the physical property of the wave that corresponds with pitch. So the fundamental frequency is generally what we hear as pitch. So a sine wave has fundamental only, so we don't hear any overtones. But overtones or harmonics contribute to what we hear as the timbre. And almost all of the sounds we have are can be broken down into components of other frequencies. So overtones are frequencies that sound above the fundamental, and harmonics are overtones at whole number multiples of the fundamental. So if we have a low C, the overtone series is an octave, a fifth, octave, 3, 5, flat 7, 1, 2, 3, etc. And they get real close together when we get up high. So if you took a string and vibrated it, this is the fundamental, one vibration of the string. If you knocked it in half, it would be here, and put that in half, it's there, etc. There's a really good example of this in the other What's Up with Noises video that's also going to be in this sequence of videos. So Jean-Baptiste Fourier was a French mathematician, and he had a theory that any complex signal can be represented by an infinite number of sinusoids or sine waves at the proper frequency, amplitude, and phase. So you can take a complicated waveform and represent it by breaking it down into its components. So when we talk about overtones, that's really what we're talking about, is those components. And this whole thing works because waves have an additive property. When we put all these sound waves out in the space together, they add together to create a wave. And I'll give you a good visual demonstration of that in another one of these videos. So they have a property of summation, and they add or subtract depending on their phase. That's how noise-canceling headphones work. If you have a constant noise in the background, there's a headphone or a microphone in the headphones, and it takes that noise and inverts it. So every time the noise sound goes up, the inverted version goes down and they cancel out. Again, I'll demonstrate that in the next video. So the third physical property of a wave that we're going to talk about is spectrum, which is the combination of sinusoids known as a signal spectrum. So we use words like bright or dark to describe timbre. So spectrum is the physical property, timbre is the perceptual property. So the spectrum is how much energy is in the overtones, and the timbre is how we understand, or like how we hear that sound. So this is a spectrogram. So this axis is time and this axis is frequency. And the red is the more intense level, right? So you see over time there was essentially no sound here, and then a sound started, and then the sound changed, and then we have another sound. So most of the frequency spectrum is represented here, and a lot of it is represented here, and here it's more spread out. So I would say, and I don't know what sound this represents, this is just a picture I found on the internet, but I'm going to say it's probably someone saying a word like shoot. So sh has a lot of noise content here. Ooh, the O's, the vowels in the middle, are more tonal, right? So you see like there's sort of just octaves and overtones here, very clearly articulated. And then t, the end of the word, has a lot of sound. So shoot, right? So that's the spectrogram there. The other way we can look at sounds is the amplitude envelope, which we look at in terms of attack, decay, sustain, and release. So this would be a sound similar like to a plucked guitar string. There's a sharp attack, and then it quickly comes down, and then we have the sustain level, and then it releases. So if you think of something like a snare drum, it would be almost all attack and release. Pop, right? Just attack and release. Or something like an organ, there's almost no decay. You press the key and it attacks, and then you have the sustain level, and then the release is very fast. So that would, an organ would look more like just a brick. So this is the amplitude envelope, or the amplitude of the sound over time. So to review, our perceptual qualities are pitch, loudness, timbre. Our physical qualities are frequency, amplitude, and spectrum. So frequency is the physical quality that maps to the perceptual quality of pitch. Amplitude is the physical quality that maps to the perceptual quality of loudness. And spectrum is the physical quality that maps to the perceptual quality of timbre.